Hello, everybody. My name is Hassan and welcome to our webinar on managing ML lifecycle with MLflow. In this webinar, we shall discuss a tool called MLflow and how it could help data scientists, data engineer, and business team to work in unified managed platforms, something like an ecosystem to create value. So MLflow is an open source platform for managing end-to-end machine learning lifecycle and is gaining a lot of attention recently in data science community, actually for its usability and its integration of different pipelines. So let's start this session. Something about myself. My name is Hassan Sharmani. I'm in data science industry and academia for over a decade. I hold a PhD degree in analytics and information system. My research areas are mostly related with sequential model, time series, and natural language processing. But now I'm kind of pivoting more into MLOps area. And there is a little bit story about it. I love experimenting with different models and their optimization algorithms. However, I was a bit surprised to see how these models never see that level of production value that they deserve, because there is a lot of hard work done on experimentation and on model development, on feature engineering, but then it doesn't create that much value when it goes in production. And this is highly due to lack of understanding of machine learning workflow and differences in experiment and production phase. So this urged me to extend my knowledge. In Royal Cyber, I'm working on end-to-end machine learning project approach that is from data collection to application working in production. This gives me a lot of satisfaction seeing a real value for data science project. Something about Royal Cyber, we are 1200 plus member company, 8 plus location around the globe. We have very strong cloud practice, having around 300 cloud experts. Most of them are certified. We keep diverse cloud portfolio in terms of certifications such as AWS, GCP, Azure, IBM. We have also a large open source practice where we work with open source tools set to solve machine learning challenges, where we can actually help you as a client organization. If you want to know more about us, please shoot an email to us and we'll love to tell us more about ourselves and about our practices. So something about MLOps. MLOps is a set of practices for collaboration and communication between data scientist, operation team, and I would say data engineering team as well. So by combining these all energy pieces, they actually help to deploy, run, and train our AI models. So it's kind of a combination of machine learning, DevOps, and data engineering. And slowly, this is evolving into in itself as an independent approach, calling MLOps. And we are getting a lot of MLOps experts in market, so this title is becoming more and more familiar. MLOps applies to entire life cycle, that is data gathering, model creation, model validation, model deployment, orchestration, tracking our model once it's deployed in practice, diagnosis in case our model results get worse. So it is pretty much an end-to-end approach. And let me elaborate a little bit more about its key phases. As I was saying in my introduction, is that, excuse me. So first phase is data gathering. This is our phase where our data engineers kind of provide us data. Then data scientists work with EDAs. They find different pattern in that data. And based on this information, if they need to have a data transformation, that is preparation for our model, they do that. Feature engineering, that is adding more features, could also be part of it. It's a very famous and known practice in Kaggle challenges. Then comes model training and development. So first part is that we check one model, then we run multiple models, we select best model out of them, then we do hyperparameter tuning. And once we know kind of, which model is there, we validate our different models based on their results. And for example, if our matrix of evaluation is accuracy, if we have highest accuracy, we put that model in survey. So I'm keeping it more and more simple. There are definitely, it's not that simple part, but these five phases are known pretty much to data scientists. Mostly we work in our Jupyter notebooks, this environment where we study most of algorithm techniques like random forest, XGP. If you are working with time series, we go in ARIMA and SARIMA models. So this is very famous in universities and academia, also in industry. People love to work on this. But what about once these models go into production? That is about survey. Now that's completely, not completely, but that is a different story. Only 50% of our job is done and 50% rest is actually remaining. So once model goes into survey, we need to also take care of our model scheduling and its model monitoring. By scheduling, I mean how often we would again train our model. Because mind you, data science practice is different from software engineering because it's not static, it's very dynamic. Our data gets updated. With that, we also update our models. That is, we retrain our models, and we might have different versions of model. We might have different versions of our data. So it's combination of code, data, and model. And due to that, when we have model retraining in production, we might have multiple versions of model. And if we don't have an effective way, it's very easy to get overwhelmed and make it kind of very messy process. So MLOps actually helps us in overcoming these issues. So as I was saying, that models are made, and we know a lot of techniques how to create a good model that is, for example, working with random forest. We know how to optimize different parameters. But what about once it go into production? So model performance actually determined in practice mostly by data scientists, and they do it manually, which is number one, very cumbersome process. If you are working with a lot of models, let's say weekly, then it creates a lot of problem by doing everything manually. And second, most of organizations are moving now to real-time scenarios. So how would you, in that case, actually monitor your model's performance? So that would be a challenge. And other challenge is that in data science team, there are a lot of different roles. There are data engineers. There are data engineers who actually work on cleaning and providing different pipelines of data. Then there are data scientists who work on feature engineering, work on model optimization, and finally do different experiments to make a good model. Then there are machine learning engineers who take care of different pipelines, write different script, uh, and on operation side, we have mostly DevOps, and all of them have a pretty much different language to be spoken. So for example, if you have a data leakage problem, DevOps team, they cannot know what is happening or how to fix that. They might know what data leakage is, but they don't know how to fix it. So for that, they would again depend on data scientists. So because of this dependency, there needs to be a system which kind of unifies all these practices, somewhat kind of an ecosystem. And this dependence actually kind of becomes sometime a bottleneck if those teams are not working in same office, or perhaps if those teams are only communicated via email, or their communication is only verbal. So MLOps actually provides some kind of a practice system where everybody would kind of gel together as a team, and they know what is happening in entire process. And I'll come back to that in MLOps. So something about Databricks, it's a secure cloud-based machine learning and big data platform. It accelerates innovation by unifying data science data scientists, data engineers, and our business team. And this unified data analytics platform works in a way to form an ecosystem. Sorry to repeat this term a lot, but this interaction is much more easier, and dependencies actually do not become bottleneck. Rather, they complement the entire workflow. Uh, Creators of this Databricks are actually Spark creators, and Databricks has recently brought forward Spark 3.0, uh, Delta Lake, Koalas. So Koalas is Panda's API on top of Apache Spark, and MLflow. So earlier on, it only understood as a model registry component, but it is more than that. The good thing is that they are open source, and you can very easily integrate them not only with, for example, one cloud, but with other cloud platforms as well. So let's talk about MLflow now. So MLflow manages end-to-end ML lifecycle. It helps streamline ML development, including tracking experiments, packaging code into reproducible runs, and sharing and deploying our models. So over here, we work with any ML library, algorithm, development tool, or language, and it's integrated very easily. It is designed to work with various clouds. It could be easily integrated with various open source machine learning frameworks such as Apache Spark, TensorFlow, and scikit-learn. So you don't need to be only stick to one stack in your project. If you are working on different stacks, it still would translate it. Uh, so in one of our previous webinar, we talked about Kubeflow, and it had different components. So like Kubeflow, MLflow also has different components. So in first one is MLflow tracking. It has API and user interface component that records data about ML experiment and permit queries. It supports Python, various API like REST, Java API, and R API. Some of main components record for each run are source, code version, parameters, that is model parameters, model artifacts, such as if you have done some kind of feature engineering, start and end time, its metrics. Second component is ML project. It does package data science code in reproducible and reusable way according to conventions. So what happens is that if I'm leading a team and I'm working closely with other data scientists and perhaps data engineers, I can actually generate something on their machine as well. So sometimes we have different versions of library. So when we try to kind of replicate our results, they actually don't go as we plan because we are using different versions of our library. So this is taken care of over here. So projects component come with an API, command line, tools designed for running projects. Features ensure project chain into ML workflow. So ML projects actually organize projects file and folders, create files, name ML projects, for example, kind of a YAML file, configurable per data science project needs. So properties of this YAML file could be name, environment, and entry point. Third component is ML models. So ML model package actually model, just like MLflow projects package its whole project. So now we are only talking about model. So model packaging format and tools permit easy deployment of same model from any ML library, be it scikit-learn, be it PyTorch, Keras, whatever. And these models could be served to batch or real-time scoring on platforms such as Docker, Apache Spark, Azure ML, or AWS SageMaker. So they don't depend on one cloud platform, as I earlier on explained. It permits adding more metadata to MLflow model. So it contains model signature and model input example. So final stage or component is MLflow registry. It provides API and user interface for centrally management of models and their lifecycle. Registry provide model lineage, model versioning, annotation, and stage transition. It acts as collaboration hub where teams can share ML model, work together from experimentation to online testing and production, integrate with approval and governance workflow. So there are different phases. For example, if I'm working on a model and I have tested, so for example, if a junior data scientist would send me and I'm leading that team, I would first like to test that model, and that model would be presented to me in a form that I could, test it. So it would be called staging. So once I would test this model and let's say I reject this model and say, no, let's do more experimentation on that, it would go back into experimentation stage. And then again, a new model would be sent later, maybe after 1 week. And hopefully it's a good model. So I would put that model into production stage. And in production stage, it would start working. But as time would pass, I might find that something is happening to this model. So I would, as a backup plan, as a contingency plan, I would keep another model, which is second best model, as in staging, so that if my main model in production fails, I have something in backup that would already take on. So by this way, we can monitor our machine learning deployments and their performances. And so some of the key components are register model, their versions, model stage, annotation, and description. They could be with a register ID or with the help of a pickle file. So it's time to see all this conceptual part into our demo. So I would thank Databricks open source tutorials and their blogs, which have actually helped us to compile these two demo. So first is prediction of petrol consumption across different states in USA based on these key features: gasoline tax, which is in cents, per capita income, which is in US dollars, paved highway, which is in miles, and population of people with driving license. And with these four features, we are going to predict our gasoline consumption. And since our target variable is a continuous variable, clearly it is a regression problem. We would use very simple scikit-learn library and model would be random for us. Since this is not a very much a tutorial about data science, so I won't do a lot of experimentation with models. Also, our evaluation matrices are mean absolute error, mean square error, root mean squared error, R squared. We all know, might have studied them in econometrics. If not, just refresh them by Googling. Uh, so let's go towards demo and give me a minute to change my screen. So for our demo, here we have environment of Databricks. This is our old friend Jupyter Notebooks. And so just to give you an overview, we have workspace where we can find different users and their notebooks in repos. We can have, if we want to uh, commit our code right away to Git. So those who are really familiar with GitHub, they can take care of their code versioning. Then there is data if you want to use data. In compute, we have a cluster. So one of our cluster is running right now. So let's go to our first case, which is petrol consumption. So over here, the way I have written code is using a method of class. A better approach could have been to create estimators and transformers and then calling up their libraries. Nevertheless, this still works pretty well. And what we have done is in first command, read the data. Here are our four features, and we are predicting this feature. So it's our target variable. Describe command, and then we are using random forest. So what is happening in the code is that we are giving estimators from 20 to 20 with an increment of 50. So that is, we would have 20, 70, then 120, and so on and so forth. With depth, we are starting with 0, and each iteration would have 2 plus. That is, we would have 3 iterations, and we would have like 2, 4, 6 steps. So I have already run this experiment, and if we want to go over here, against each block, we can write a comment so that other teammate could read it and could have either add their comment or could respond to that comment. In experiment, we can see our experiment parts. So over here, it's our experiment, and in comments, you can see our comments part. One option is also pretty useful, which is scheduling. We can schedule. All we need to is connect to our cluster, schedule our job at this given time, whatever we want to use, we can schedule it, and we would always notify whenever there is a failure. So let's go towards our experiment part, and let me run this one. So we have done overall 4 experiments as there was a loop of it, and 2, 4, 6, and 8 maximum depth. So let's see what are our experiments are about. The interesting part is that we can compare actually two models. We have their different matrices and their parameters, so it's very easy to compare and see which models are performing better. But for example, we want to make a comparison of two models, which are pretty good models. So we will compare them. So over here, we have like a one-to-one comparison, and not only that, but we have a scatter plot against maximum depth, and our loss function, we can change it to number of estimators as well. And against each point, we can see detailed overview. So right now it looks very simplistic, but once we have, suppose, a lot of parameters, 7 or 8 parameters that mostly random forest has, and then we have, let's suppose, more loss functions or our error values, then it could become much more useful and become very handy. But over here, it's a simplistic version of our code. Uh, let's see how we can, for example, check each model type. So let's click on this one. And over here is the page that I was talking about earlier on. In Spark data frame format, this is our script. And in Pandas, those who really like to work with Python, this is their script. So you can invoke this ML flow run in your own notebook as well. What I want to show you here is this ML model file, which tells us about this model.pickle, and also it takes care of our run ID. So either we can use pickle file or we can use our run ID against each registration. Similarly, if we go into our YAML file, so this actually tells us what our project is using. So you can see these versions of library that it is using. So if one of my team member has done it and I want to replicate those results in my project, I can use this configuration. And similarly, we can go and see our plot. So this is our root mean square versus our estimator plot. So this gives pretty much good information. And as we have already chosen one of our better parameters, let me again go back and make sure which one was our best. So based on mean absolute error, we are choosing this one as our best model, and I'm using this one. So over here, we can register this as our best model. So now I can select a model. We have already number of models. I can write a new model, but let me overwrite on this one, guest GCP, and this model is saved here. So this is taking some time to get its registration done. So it's registered now. Let me open this one. So in this dashboard, we could also add description. We can say first version of our random forest, and we can save this one. So over here, let's suppose I want to change the status and I want to put this into production, and I say let's go for and so now I send this one. As you can see over here, it's showing into our dashboard, and to my team lead, it would go towards for an approval. So since I'm using this as a 101, more like a schizophrenic approach, so I can approve it or I can reject it. In either state, it's fine, but I would reject it. And the reason is that first, uh, is our main best practices that we first use model for staging. We would test that model and only then we can put that to production. So if I am sure I want to just myself directly transition without getting approval, uh, it's always better if you want to use approval. But since I'm now have shown you how it works. So you can say now the status has changed and now it's in staging mode. And you can say also, see also what is happening here. So in this is now in staging phase, and what we need to do is to kind of check our model. So this one is our model. It's version 5 because prior to that I have also applied this tutorial and for multiple times. So that's why this is giving a version 5, but it's very easy to take care of different versions. If we have not removed or if we are keeping our previous versions, we can very easily track these versions. So now my version 5, so over here we can track these different versions. So I want to use my version 5. I will click on this and I would go into my serving and I would enable serving. So now we have our system ready. It's also say its serving is ready, and then this version 5 that we are testing is also ready. So what I would do is I would try to implement an API in format of a JSON object, and I would send a request, and I would get a value. And based on these different features, this is our predicted value. We can always create, this is a real-time scenario. So for example, if you have a data in batch, you have 10 or 11 values, you can always check after you get ground truth and make a comparison how good your model is performing. We can use this batch system over here by using data. Let's say at the end of a week, we want to see how good our model is performing. So we would pass multiple data values, or we can also put that into our real time. But I want, because we are right now in staging phase. So what I would rather do is that I will go back and try a few more iterations with our experiment. So we were here and it was pretty simple experiment with only two parameters, nothing complicated. Suppose I want to use more parameters, want to make this situation a little more interesting. As random forest has more parameters, so we would use these parameters and we would try to see how our experiment go on. Do we get some good results or not? So let me run this, and in real time, you can also see some changes happening in our experiment window. So these are our results. Let's see how overall our experiments. like. So this is pretty much exhaustive detail. Let me scroll it over here. These are our first 4 iterations that we ran, and you can see our model in registration. And so we can observe from here that value is 48.31. We are getting some models with better values. We had something in 43 as well, 47, and so on. So suppose we can again do this comparison. We can try to see between 43 and our best registered model, what happened over here. And let's make a comparison. So one to one, we can see that using a lower number of max depth and having 120 estimators against 10 provides us better results. But for sure, we cannot say this for a fact because there are other parameters being added which were not there earlier on. So we can make these kind of comparisons always, and as we go along and make our experiment more complex. For example, we want to add more set of features, more transformations, and then more parameters. Let's suppose in the future we want to do a grid search CV and make hyperparameter optimization of our parameters, then we can make these experiments more elaborative. But for now, I will stop here. So what we do is that we will select our best model, and since our previous model has been challenged by this model, which is giving 43, so I would select this one and I would go into its detail and I would put this one now in registration, and I would again use this one to register. So it would, as usual, take few seconds and we will wait. And now it's ready. So let's go there. And again, we can first do this kind of an approval system, or we can directly go and make a pseudo level command, I would say, to make it once for all in production. So now this model would directly go into production. Let's go in model list and check. We can see we have version 5, which is in staging. We have version 6, which is in production. So this is a best practice in MLOps because we might see that for some reason, for any reason, our version 6 model might fail and our application is now working in kind of in production. So version 5 would automatically take care of the system. So once we have a model as a backup model, second best model, we would just push this model of version 5 into production so that we don't have to go back and look what is happening in experiments and all that. Even a person who has no background with data science can do that. So it only requires DevOps or MLOps training. So let me go for this model and we will use our version 6 model now. So since this is in production, we can again go in serving, do the same experiment again, but I won't do that. Rather, we would use our time and we would go for our second demo. But you get the picture that best model is in production. Now you can serve it direct to your user interface or your dashboard, some application, and it would work unless and until you want to do another iteration of your training, perhaps your model, or you might have new data and you want to retrain your model. So new versions would be formed accordingly. And we are on our second demo, which is to predict authenticity of our banknote. So if we have our variance or transformed image, cuteness, entropy, and curtices feature, we want to predict whether given banknote is authentic or fake. So this one definitely has a very high value in industries, especially in banking and finance industry. In markets like subcontinent, it's really, really valuable. So since it's a, excuse me, since it's a classification problem. So now we won't be using regression matrix of evaluation. We would be using accuracy. You might be thinking that no, accuracy is not the one way. We can definitely use F1 recall precision. We would calculate them, but for the ease of our discussion, we won't be going into this, that what is the difference between all these matrices, because that would be a different discussion. Similarly, we would also calculate confusion matrix, and we would see based on these different parameters that against what value we actually get better results, and again how we can track our experiment part, how we can package our model, how can we package our project, and in the end, how we can register this project. So going back to our Azure Databricks. So here we are with our tutorial about classification problem, and again we have done pretty much same thing. And since I have already have this run once, I won't be running it again. I would be just showing you this data. It's in the form of class 0 or 1, 1 being fake and 0 being authentic, 4 variables. Pretty simple. We have done the same thing with random forest, excuse me for coughing. And we have again put +2 depth, and we have this time taken a range of our estimator from 10 to 40. That is, we would have 3 combinations, 10, 20, and 30, and depth would increase by 2. And let me open up this in experiment because it would look better over there. And this is the result. So we can see we have multiple accuracy values of 90%, 95%, and 90%, and definitely also different values of one score. And we can, as usual, look up. We can, in a classical way, always make a comparison if we want, that that I have already shown you. So it's pretty much a repetition of what we have already done. So we have, I think, deployed this in system, but let me still check this model. Is it already in its deployment? So I think it's not. So let me again go back and deploy these models. So I wonder why this one is not production. Okay, so it is deployed, but it's not uh, in staging or production environment. That's why it was not showing that in our logs of model. So again, we can first put into staging, or direct we can go for transition. So I would take this liberty and directly go towards transition. And yes, so it's now directly into production. And if we try to go and find out where this model is, was it somewhere here? Yeah, it's actually here, and it's in production directly. So excuse me for this intelligence. Couple of experiments are happening here. So just like the way we have done, can enable this serving. So now we are ready. It's in production, and we can check whether our API would work just like the last time. So we are checking, we are sending, and it says no. So this means that this is fine. This note is not fake. Just to check one more, because we had a pretty high accuracy this time. And so, yeah, it says 1. So with these characteristics or these attributes, our banking note would be fake. So with this, I would rest my case. If we want to kind of repeat what we studied, so finally, there is one solution architect that at Royal Cyber we have been using to solve a case study, one of a case study for our client. And we have data coming from, let's say, different sources. and we are doing feature engineering. But the interesting part is that they are both. They could be coming in real time and coming maybe in batch. In Databricks, we do this experimentation, then we do this building our data, and then applying model, finally save our models, and then we go into MLflow word and we serve our model. On the other side, our transform features are coming in, and then similarly, we can take care of our model. So the good thing is that if we want to retrain, we will again go back to this window and we will retrain our system. So just an example that how in real world scenario, a solution architect that would use MLflow could come in existence. And as you can see, MLflow is something that you can use as a very complementary component. Just at the end of your experiments, you can use it. So you don't need to start it with your experimentation start or your experiment phase, especially when you are working with your models. You don't need to use MLflow. Obviously, you can use MLflow for visualization and some other work, but at the point of this webinar or this session is that the real cream comes when your models actually come into deployment phase, and especially when it's an online and offline. So over here, we actually couldn't see a real-time scenario. So I think in coming session, that is another case that we could build, and we could show that how we can serve our model, and our model is consuming real-time data, because in real-time data, there are other issues such as efficiency and latency and many other issues that we don't see in batch data. But this is pretty much all from my side. And I think we are pretty much close to over time. So I would hope that we have clarified everything, and let's move to question and answer session. Thank you.